All right, so get ready, because today we are tackling a question that has puzzled pretty much everyone forever. Like, why is there something rather than nothing? Why does anything exist at all? And we've got some research and notes here, and let me tell you, it's a fascinating approach to this question.
Yeah, it really pushes us to the limits of what we know. And what I think is so interesting is that before we can even try to answer this question, we really need to redefine what we even mean by nothing.
Because when I think of nothing, I just picture empty space. Like, that's it.
Right.
But it turns out there are all these different levels of nothing. And the research that we have dives into 3 specific types, each one more mind-boggling than the last.
Yeah, so think about the emptiest thing that you could possibly imagine. And that's actually where we start, a universe that's completely void of matter, energy, even forces like gravity.
So like a superpowered vacuum cleaner just went through and sucked out everything. Kind of like, those ultra-high vacuum chambers they have in labs, but on a cosmic scale.
Oh, exactly.
So, but you're saying that's not even truly nothing.
Exactly. So this type 1 nothing, as we call it, still has space and time. It's kind of like a stage set for a play. It's ready for the actors and the props, but they just haven't arrived yet.
Okay, so what's the next level of nothing then?
So type 2 nothing goes a step further and removes even the fabric of space-time.
Wait, so if there's no space and no time, where do the laws of physics even exist?
That's the big question. So, it's like having a blueprint for a house but no land to actually build it on. So we've got these rules, these laws of physics, but there's no universe for them to apply to.
Okay.
So it raises this whole other question of where did those laws even come from if there's no pre-existing framework for them?
Right. It's a real chicken and egg problem there.
Yeah.
Okay, so if type 2 nothing has no space-time, what could possibly be like nothing other than that?
Well, that leads us to the ultimate head scratcher, and this is type 3 nothing. No things, no fields, no space-time, no laws, no framework. It's the concept of nothing taken to its absolute extreme.
Whoa. Trying to picture that makes my brain hurt a little bit, I'll be honest.
Yeah.
It's like trying to imagine a color that you've never seen before.
Exactly. Even trying to describe it is a challenge because by calling it a void, it implies that there's something there to be empty.
Right.
So this type of nothing really pushes us to the very limits of our understanding and even our language.
Okay, so we've got these different levels of nothing, but here's what I find really baffling. Our universe, with all its stars, galaxies, planets, and us, it seems to have a net worth of 0.
You're right, it's kind of wild. So all the positive energy from matter and energy in the observable universe is perfectly balanced out by the negative energy of gravity.
Huh. So it's like the universe pulled off the ultimate magic trick. It created all this something, but didn't actually change the overall balance.
That's a really good way to think about it. It really does reframe this question of something from nothing, right? Because the real mystery is, how did the universe borrow the resources to come into being and create all this complexity while maintaining that network of 0?
Right, like where did it get the loan to buy all this stuff?
Exactly.
Okay, so to try and explain that, scientists have come up with some pretty wild theories.
They have.
I mean, when I was going through all this research, every theory is more mind-boggling than the last. We've got quantum fluctuations, colliding universes, black holes, birthing new universes. It's like the universe has a whole bag of tricks.
It really does. And each of these theories tries to explain how something could come from what we think of as nothing. One of the most intriguing ones is the idea of quantum fluctuations.
Okay, so break that down for me. What is a quantum fluctuation?
Imagine a universe where particles can kind of spontaneously appear and disappear. It's like these tiny sparks of existence, flickering in and out of reality. And that's essentially what quantum fluctuations are.
So you're saying these particles just pop into existence out of thin air?
Well, not exactly out of thin air, but more from a state of quantum uncertainty. So in the quantum realm, things aren't so clear-cut. There's a certain fuzziness to reality, and that kind of allows for particles to momentarily exist even in a vacuum.
Okay, I think I'm starting to get that. But how does that explain the entire universe? It seems like a pretty big leap from tiny particles to stars and galaxies and all that.
Yeah, you're right. It's not a complete explanation. Quantum fluctuations, while really fascinating, mostly explain the creation of particles, but not the origin of the universe itself.
Right. Okay, so what about those other theories, like the idea of colliding universes?
Right, so that's what we call the ekpyrotic scenario, and that suggests that our universe might actually be the result of a collision between two pre-existing universes. So imagine these universes as membranes or brains kind of floating in this higher dimensional space, and when they collide, the energy from that collision could spark the creation of a new universe, which would be ours.
Whoa, so it's like a cosmic fender bender created our reality.
Yeah, something like that.
But hold on, wouldn't that mean there were already universes before ours? And where did those come from?
Yeah, exactly. So it kind of pushes the question back a step, but doesn't quite solve the ultimate mystery of how it all started.
Okay, and then there was also something about black holes birthing new universes. That sounds pretty intense.
It does. So some physicists propose that the singularity at the heart of a black hole, where all that matter is compressed to an unimaginable density, could actually be the seed for a new universe.
Whoa, so like a star collapses and then boom, a whole new reality is born.
It is a very thought-provoking concept,
Yeah.
but even with all these mind-bending theories, we still run into a pretty big limitation. Our current understanding of physics can only take us back to a certain point in time.
Oh, you're talking about the Planck time, right?
Exactly.
I remember reading about that. It's like 10 to the power of negative 43 seconds, right?
Yeah, you got it. The Planck time is like the tiniest sliver of time you can possibly imagine.
Wow.
And beyond that point, our current laws of physics, they just completely break down. It's like we hit this cosmic brick wall. We just don't have the tools to understand what might have happened before that.
So even with all of our amazing scientific advancements, we're still just looking through this tiny little window at the vastness of the universe.
Exactly.
Wow. But I have to say, that's kind of exciting.
It is.
It makes you wonder if there might be like a whole new set of physics, a whole new way of understanding reality that we haven't even begun to imagine yet.
Right. And maybe that new understanding will help us finally answer this question. Why is there something rather than nothing?
It's like we're missing this crucial piece of the puzzle.
Yeah.
And that missing piece could change our entire perspective on the universe.
And that's what drives scientific inquiry, this constant search for answers.
Yeah, it's humble.
It reminds us that despite all that we've learned, we're really still just at the very beginning of understanding this grand cosmic drama.
It's really amazing to think that a question as simple as, why is there something rather than nothing, can lead us down this rabbit hole of cosmic mysteries.
It really is. It's a question that's captivated thinkers for centuries, and it's one that continues to challenge our understanding of the universe and, where we fit into all of it.
Well, we've explored these different levels of nothing. We've talked about these mind-bending scientific theories. We even kind of bumped up against the limits of what we currently understand about physics.
We did.
So what's the biggest takeaway here? What can we, the listeners, what can they glean from all of this?
I think the most important lesson is that it's okay to not know everything, to embrace the uncertainty. We may never have like a definitive answer to why there's something rather than nothing.
Right.
But the journey of exploring this question, I think, can really expand our awareness and open our minds to new possibilities that we might not have considered otherwise.
I love that. And it makes me think of that saying, the more you learn, the more you realize you don't know. And that realization, instead of being discouraging, should fill us with this sense of wonder and excitement.
Right. There's so much more out there,
Yeah.
so many more layers to peel back.
It's true. And it reminds me of that feeling you get when you're a kid. You first learn about how vast space is.
Yeah,
It's both awe-inspiring and humbling at the same time.
absolutely. And I think that sense of awe is something that we should really try to hold on to, even as we delve deeper into all the complexities of science.
Yeah.
Sometimes the most profound questions, they don't have easy answers, but it's the act of asking those questions and, grappling with the unknown that really pushes us forward.
Well said. And as we wrap up this deep dive into the mystery of existence, I want to leave our listeners with one final thought.
Okay.
The next time you look up at the night sky, don't just see the stars.
Yeah.
See the infinite possibilities.
I love that.
Let your mind wander to the edges of the universe and beyond. Question those assumptions about nothing and something. And remember, the universe is full of mysteries, and that's what makes it so captivating.
Absolutely.
So keep asking questions, keep exploring, and keep diving deep. Until next time, fellow deep divers.